Hello everyone, my name is Mr. Ibrahim Faisal. I'm a math teacher. Today we are going to revise math for grade 8 students. So let us begin. I divided the revision into 3 lessons. Here, this is the first lesson. All the videos you will find them in our page in Facebook, Private Teachers. So question 1, put true or false question. So the first one from unit 1, 2 over 5 is a rational decimal number. So we have here a term rational number. Rational number. So rational numbers contains the rational number set contains two major sets. The first one is the rational decimal number. The second one is repeating numbers. So to differentiate between the rational decimal number and rational repeating number, we look at the denominator of the fraction. If the denominator of the fraction is 2 or one of the powers of 2, like 4, 8, 16, and so on, or 5 and the power of 5, 25, 125, and so on, or 10, 100, 1000, and so on. In this case, when we find the denominator, one of those numbers, we call it is a rational number. So the first one is true. Get it? So moving to the second one, again is 4 to the base 3 is equal to 4 to the power of 2. Look here, again is 4 to the base 3. So the base should be what? The base should be 3. This is the base, this is the power. Here the base is given 3, but here is given 4. So the first one is false. The irrational number q star. Here, this is another set of numbers. We have rational numbers and we have irrational numbers. So the irrational numbers q star can be put in the form of a over b, and this is false because the difference between the rational numbers and the irrational numbers, that the irrational numbers cannot be put as a over b. Number 4, the mode is the value which occurs the most. Yeah, this is true. This is the definition of the mode. It is the value that occurs the most. Number 5, the expression x to the power of 2 plus 4x plus y to the power of 2 is a perfect square. Here, so the question here is about checking whether this expression is a perfect square or not. To make it, we have to make it, we have a rule which says we bring the square root of the first one, so the square root of x to the power of 2, and then we bring the square root of the third one, which is the first one is x to the power of 2. We bring the square root of it, and then we bring the square root of the last one, which is y to the power of 2. We multiply them together, and we multiply them by 2. So x to the power of 2, the square root of it is x. The square root of y to the power of 2 is y. And when we multiply them by 2, so the answer is 2xy. And we check the middle term. The middle term is 4xy, not 2xy. So in this case, we're not going to say this one is true. So it is false. So number 6, the shortest line segment from a given point to a straight line is the perpendicular. And this is true. This is theorem, one of the theorem of the book. The shortest line segment from a given point to a straight line is the perpendicular. It is theorem 3 in unit 6. Now, the number 1.21211 212221 is rational repeating number, and the condition of the repeating number is to be repeated by the same way. This is here we say 2 1 2 1, but this is 3 twos. That means the 2 is not repeated by the same way, so this is not a rational repeating number. yet it is irrational number because it is not terminating. Here we have this arrow here, that means then this number is not terminating, and also it is not repeated by the same way, by the same pattern. So we call this number is irrational number, not rational repeating number. So it is false. Number 8, if f from I to I, here we mean by I the integer number, like the positive numbers, the 0 and the negative numbers, defined by the rule f of x is equal to x to the power of 2, then f is 1 to 1. And this will be false because if we take 3 as numbers from the domain, uh, when we put it in the function, it becomes 3 to the power of 2, which is 9. So 3 is connected to 9, and if we say negative 3, also it will be put in the form f of x. So negative 3 to the power of 2 is equal to positive 9 also. So 3 to the positive 9 and negative 3 to the positive 9. So the element 9 here represent or is connected or represent an image to two numbers. So it is not 1 to 1, because the condition of 1 to 1 that each image in the codomain is an image only for one element from the domain. So the answer here is false because it is not 1 to 1. Number 9, any point lies on the first quarter x is greater than 0, y is greater than 0. X is greater than 0, that means it is positive, the value by positive sign, and y is greater than 0, that means also by positive sign. That means in the Cartesian plane, here we write the positive numbers from the x-axis. Here we write the positive number from the y-axis. So positive and positive lies on the first quarter, and that means this information is true. Number 10, all the medians of the triangle meet at one point. Yes, this is true. This is a theorem, the fourth theorem in chapter 4, transversals and medians. All the medians meet at one point, and we call this point the centroid, and it divides the median by the ratio 2 to 1 from the vertex side. That means this information is true. Then number 11, from the equation x, sorry, here this is x to the power of 2, x to the power of 2 minus x minus 6 is equal to 0. The multiplication of the two roots is 6. So here we have to find the multiplication of the two roots and also the sum of the two roots from the equation directly. So the multiplication of the two roots is 6. So the rule of the multiplication of the two roots is the absolute term. If you want to find the multiplication of the two roots directly from the equation, you just look at the absolute term and you take it by its sign. So here it is what, negative 6, and what is written here is what, 6. So this information is false. The perpendicular bisector to any chord passes through the center of the circle. This information is true. It is one of the theorems of the circle. The perpendicular bisector to any chord passes through the center of the circle. 12 over 15 is not terminating decimal. As I told you, to find the difference between the terminating decimal and between the repeating decimal, we look at the denominator. If it is one of the powers of 2 or 5 or 10, that means it is terminating decimal. If not, that means it is repeating number. But here, look at this one. We look at the denominators directly after this, after we put the fraction in the simplest form. So our fraction here is not put in the simplest form, so we put it in the simplest form. 12 and 15 in table 3, so we divide by 3, here 4, and here we divide by 3, here 5. So the fraction is 4 over 5, and now we find the denominator is 1 of the power of 5. That means is not a terminating decimal. False, because it is a terminating decimal. So this information is false because it is a terminating decimal, not terminating decimal. So the hypotenuse is the longest side in the right angle triangle, and this information is true because in any triangle, in any right angle triangle, we will find that the hypotenuse is the longest one, and this is one of the results in theorem 2 in unit 6. Log 1 to the base x is equal to 0. We if you don't understand it, or if you cannot answer it directly, we can put it in the form of in the form of base and bar, and then you will find the answer. So x here, it represents the base, 0 here represents the bar, equals, our number here represents the answer. So x to the power of 0 is equal to 1, and this information is true because any number, any variable, anything is to the power of 0 is equal to 1. So this information is true. The function is a special type of relations. Yes, because we have two conditions. If we find in any relations that the two conditions are applied, then it will become a function. The two conditions, the first one, that all the elements in the domain are connected, and all the elements in the domain are connected to only one element in the codomain. So this information is true. -3 plus 3 is equal to 0 according to the identity element of addition. And here some students might get mistaken because there is two properties are similar to each other. The first one is the identity element of addition, and the second one is the additive inverse. And the difference between them, if you find the zero as an answer, so this will be an additive inverse. But if you find 0 added to a number, if you find 0 added to a number in the left side, that means it is the identity element of addition, because no change will happen to the number. But when we have the answer equals 0, that means we added two additive inverse numbers. Like here we have -3 and +3. We add them together and they are additive inverse to each other, so the answer is 0. So this is not identity element of addition, rather it is additive inverse property. If two chords in a circle are equal, then they are equidistant from the center, and this information is true. Yes, we have a theorem says if we in one circle or congruent circles, the two equal chords are equidistant, and the word equidistant, that means they are equal in distance from the center. The second degree equation, x to the power of 2 plus 16 is equal to 0, cannot be solved in R. This is one of the special cases of the second degree equation. Here we have b is equal to 0. B means the coefficient of the x here is equal to 0. To find the answer of this one, here we try to factorize this side. X to the power of 2 plus 16, this is a square number and this is a square number, but they are added. So we cannot say this is a difference between two squares. So that means we cannot factorize it, meaning that we are not going to solve it, or it doesn't have an answer in R. So this information is true because here, look, yes, he says can't be solved. So it is true because it can't be solved. The point 1 and 1 are the coordinates of the origin point, and this information is wrong because the coordinates of the origin point is 0 and 0. 0 and 0. These are the coordinates of the origin points. So this information is false. Now, the second style of the exam is the question complete. Look at the first one. The function becomes bijective if it is dash and dash. So we have three types of functions: onto, one-to-one, bijective. We know the conditions for the function to be onto, and we know the condition for the function to be one-to-one, and the condition for the function to be bijective is to be onto and one-to-one at the same time. So here, onto and one-to-one. Dash is a part of the circle included between arc and two radii. Included between arc and two radii, this way. This is the circle. These are the two radii, and this is the arc. These are the two radius, and this is the arc. So here we mean this one. We mean this part. So this part in circle, we call it the sector. The point 50 lies on dash axis. We look at the point here, 50. So the coordinates of y is 0. That means the point will not be on in y, so it is will be on, yeah, this is the x-axis. So the 5 is the x coordinate, so the point will be on the x-axis. Q intersection with Q star is equal to what? And if we look at Q and Q star, we find that Q and Q star are two separated sets, because Q contains the rational numbers and Q star contains the irrational numbers, and we cannot find an element is found in the rational numbers and the irrational numbers at the same time. So this information, or sorry, so here, to complete this one, the answer will be the empty set or phi. If f of x is equal to x to the power of 2 minus 1, then f of 3 is equal to, so to answer this one, we just are going to substitute the value of x by 3. So it becomes 3 to the power of 2 minus 1. 3 to the power of 2 is equal to 9. 9 minus 1 is equal to 8. X to the power of 0, we mentioned it previously. We said that each number or variable, whatever it is, to the power of 0, that means it is equal to 1. So the length of any side in the triangle is greater than, this is one of the results of unit 6. Yes, unit 6, the last theorem, that the sum of two sides is greater than the third side. The sum of two sides is greater than the third side. And here the length of any side in the triangle is greater than the difference between the two sides. This is, as a result, you can find it in on the book. So the difference between the other two sides. Now look at it carefully. The length of any side is greater than the difference, and it is less than the sum. Take it as a rule. The length of the of any side in the triangle is greater than the difference between the two sides and less than the sum of the two sides. Number 8, from the data 4, 5, 7, 2, the mode. And we know that the mode, we mentioned it in the first question, the mode is the value or the observation that occurs the most. Here we have 4 is repeated twice, that means the mode is 4. If if x plus 3 is equal to 5, then x is equal to 2, according to, so the 5 here we can say 2 plus 3, from which we can say the x is equal to 2, and this property we call it the brevity. We call it the brevity. The relation between the centers of the intervals and the frequencies are called If you remember the figure, we call it the frequency polygon. We draw it this way. So it is what? It is a connection between the centers of the intervals. It is a connection between centers of the intervals and frequencies. So here the relation between the centers of the interval and the frequencies is called the frequency polygon. The third style of the exam, draw a circle around the correct answer. Here, look at the options carefully. Sometimes two options will be the answer. Two options will be the answers. Here, the first one, in the cyclic quadrilateral, opposite angles are yes, supplementary. Supplementary means the sum between them, or the sum of them is equal to 180. Complementary, that means the sum of them is equal to 90. The word complementary, that means the sum of them is 90. Supplementary, that means the sum of them is 180. So in any cyclic quadrilateral, each opposite sides or each opposite angles are supplementary. The sum of them is 180. Number two, we will put the suitable sign 2.13 bar, 2.13 bar. So here look, the bar here only above the 3, and here the bar is above the 1 and the 3 together. So to put the suitable sign, or to add them or to subtract them, we have to expand the number for let us say for just 4 digits. For example, here 2 point. If we want to expand the first one, 1, the bar on above the 3, so we are going just to expand the 3. This is the first one. And look at the second one. It is 2.13. So here we are going to repeat the 13, all of it, and so on. To compare between them, we look 2 here, we have 2, 1 here, we have 1, 3 here, we have 3, 3 here, we have 1. So the bigger number is this one. So which means that this one, so the sign will be greater than. The solution set of the equation x to the power of 2 minus 25 is equal to 0. As I told you, this is a special case of a second degree equation. Here we don't have the middle term, so the b is equal to 0. So we are going to factorize this side. X to the power of 2 is a square number, minus 25 is a square number. So that means it is a difference between two squares. A difference between two squares, we are going to open two brackets, x minus 5 and x plus 5. We say either x minus 5 is equal to 0, therefore x is equal to 5, or x plus 5 is equal to 0, therefore x is equal to negative 5. So here it is obvious that the solution set is 5 and negative 5. Look carefully. If this sign is minus, we can find an answer. If this sign is plus, so the answer will be the empty set. If the arithmetic mean for 7, 8, 2, x, 3 is 6, then x is equal to, here the arithmetic mean, we find it by adding the values together, and dividing it by the number of the values. Here, how many values we have? 1, 2, 3, 4, 5. So we have 5 values. And the arithmetic mean is equal to 6. So the sum of the values is equal to 5 times 6, which is equal to 30, which is equal to 30. Then we look at the values that given here. 7 plus 8 is equal to 15. 15 plus 2 or 15 plus 5 is equal to 20. Therefore, from the difference between the 30 and the 20, which is 10, that means the x is equal to 10. So this is the answer. The arithmetic mean is the sum of the values divided by the number of the values. The sum of the values is the arithmetic mean multiplied by the number of the values. For in the third lesson, you will find many examples about this one, and you are going to understand it well. Just stay tuned, and everything will be clear, inshallah. Then the centroid divides the medians by the ratio dash from the vertex side. Here, the most important thing to focus on, which is here, this word, the vertex side. The vertex side. Sometimes the question comes as from the base side. Base, from the base side. And this is the difference. Here, this is the inverse of the vertex side. The inverse of the vertex side is the base side. So as I mentioned previously, the centroid is the point that all the medians of the triangle meet at, and it divides the median by the ratio 2 to 1 from the vertex side. Here is written vertex side, so the ratio will be 2 to 1. If it is the base side, so the ratio will be 1 to 2. Yes, the inverse of it. So the answer is 2 to 1. The range is a subset of the domain or the codomain or relation or the connection rule. So we have domain and we have codomain. The range is the set that contains all the emics, and we know that the emics are found on only on the codomain. So here the answer is the codomain. The property shown in 2 in a bracket x plus 3 is equal to 2x plus 6. If you look at it, if you look at it here, we have 2, and the sign between the 2 and the bracket is multiplication. So it is we have to expand this value to find to get the answer. Whenever we find a multiplication sign uh, outside the bracket and an addition sign inside the bracket, so it will be the distributive property. If we find here 2 plus, for example, 2 plus, then a bracket x plus 3, so between the 2 and the bracket we have plus or minus, it will be the associative property. So this is the difference between the distributive property and the associative property. We look at the number and the bracket, what is the sign between them. If we don't have sign, that means the sign is multiplication, and then it will be distributive property. Between the 2 and the bracket, if we find plus or minus, that means this will be the associative property. So this answer here now, the distributive property. The commutative property, you will understand it in the following examples. Here, the symbol or the suitable symbol in the blank I, I here is the set of the integer numbers, the positive numbers, the zero, the negative numbers. Q here is the set of the rational numbers, and we know that the rational numbers contain the integer numbers. That means I is a set of Q. So this is the answer. Here, the difference between the set and the element is element on. This is from its name, it is clear that it is for elements only, and this for sets. So between two sets, we put this sign. Between an element and a set, we put this sign. From the rational numbers, again, the rational numbers, as I told you, it contains two major sets. The first one is the repeating numbers, and the second one is the terminating numbers, terminating decimal number. So if we look at the numbers, pi is non-terminating number. Pi is 3.14 and so on. Long it is a long number. It doesn't terminate. So pi is irrational number. Take it this way. Pi is irrational number. And the square root of 13, we don't have a number. When we multiply it by itself, the answer is 13. That means we cannot find the square root of 13. And when you cannot find the square root of a number, that means it is irrational number. And then look at this number, 1.211211112. It doesn't terminate, and also it is not repeating. So it is irrational number. But look at this one, 3.7 repeating. That means this is a repeating number. So this is our answer. The fourth style of the exam, find the value. Yes, here it is about operations, addition, subtraction, multiplication, division for fractions, for integer numbers, and so on. So here 7 plus -5. So this is the rule of the addition of integer numbers. When they don't have, or when the signs are different. Here look at, the sign of 7 is positive, the sign of 5 is negative, and the operation is addition. So it is addition of different signs. Addition of different signs, we subtract the two numbers. So 7 and 5, the subtraction of them is 2, and we put the sign of the bigger number. The bigger number here is 7, and the sign of the 7 is positive. So the answer will be positive 2. 10 times 3.7 repeating. And when we say 7 repeating, that means when we take 7, another 7 will be produced. When we take also the 7, another 7 will be produced. So it will be like a wheel. No matter you take from the 7, another 7 will be produced. So here, to make it clear, just try to expand the number. 3.7 repeating, that means 3.7, 7, 7, and so on. And when we multiply it by 10, we know that we move the decimal point one place to the right, because here we multiply by 10. Because it is multiplication, we are going to go to the right, and because it is by 10, so we are going to move just one digit to the right. So the point will be here, 37.7777. And the 7 repeating here, we can put it as just 1 7 and put the bar on it. Get it? So the answer will be 37.7 repeating. Sorry. Now we have a mixed number, 2 and 3/4. We have to put it in the form of A/B. That means change the mixed number into improper fraction. It is easy. We just multiply, then we add. Here we multiply, then here we are going to add. So it becomes 2 times 4. The answer is 8. 8 plus 3, the answer is 11/4. We put the same denominator here written here. We put it here again. Now look at this one. Put x, y in an expression showing the commutative property of addition. Commutative property of addition. Firstly, because it is addition, that means we are going to use the operation, the addition operation between the x and y. And the commutative property means by changing the numbers. For example, firstly, we are going to write it x plus y. This is addition of two numbers. Then it will be equal to y plus x. So this is the commutative property. So here the answer will be x plus y is equal to y plus x, and this is the commutative property. When you find x plus y or x plus a equals a plus x, This is the commutative property, and we can find it in addition, and we can find it in subtraction. Now 6 divides by half, and we know that if we have fractions or numbers here, 6 is 6 over 1, we can consider it as a fraction. It is divided by half, so we are going to make it this way: the first number as it is, so 6, I'm going to write it 6 as it is. The division sign becomes multiplication, and we bring the reciprocal of the second number. The reciprocal means by changing the denominator to make it the numerator, and the numerator to make it denominator again, so it becomes 2 over 1, which we can say 2. So it becomes 6 times 2, which is 12. Now negative 7 minus 3. This is subtraction between integers. Look at this. This is addition between integers. This is subtraction between integers. To answer the subtraction between integers, we write the first number as it is. So the negative 7, we write it negative 7 as it is. The subtraction side becomes positive. So minus sign, we are going to change it to positive sign. And we bring the additive inverse to the second number. The second number is positive 3. The additive inverse to it is negative 3. So negative, it becomes negative 7 plus negative 3, which is negative 10. Moving on, Unit 7 questions. Unit 7 is about expanding and factorization. Expansion and factorization. The first part of this unit is expansion. So the first question, expand the following. 5y to the power of 2 times, open a bracket, 3y plus 2. To make it clear, look at it carefully. 5y to the power of 2, inside the bracket 3y plus 2. So we take 5y to the power of 2, we multiply it by the terms inside the bracket. So firstly, take the first number, the first term, 5y to the power of 2 times 3y. We multiply the numbers together. 5 times 3 is 15. Y to the power of 2 times y is y to the power of 3. So when we multiply 5y to the power of 2 times 3y, the answer is 5. 15y to the power of 3, and then multiply the 5y to the power of 2 by the 2. 5 times 2 is equal to 10 by a positive sign, because this positive and this positive, so it becomes by positive sign 10. Y to the power of 2, here we don't have y, so we put it as it is, y to the power of 2. This is the first question. The second question, we have two brackets together. We have two brackets together. The first bracket, x minus 7. The second bracket is x minus 10. So the expansion of the brackets, we take the first value from the first bracket, we multiply it by the whole bracket, and then we take the second value from the first bracket, we multiply it by the whole bracket. So when we take x, we multiply it by x. So x times x is x to the power of 2. Then we take x, we multiply it by negative 10. X times negative 10 is negative 10x. After we multiply the x, we take the 7 by its sign, which is negative 7. We multiply it by x. So negative 7 times x, which is negative 7x. And then lastly, we take negative 7 times negative 10, which is negative times negative here is positive. So negative 7 times negative 10 is positive 70. This is the first step. The second step, we have something called the like terms. The like terms, when we have the same variable by the same power. Here, the same variable by the same power. Here, x to the power of 2. We don't have any term that contains x to the power of 2. So x to the power of 2 is the final answer. Here, 10x, we have a value, or we have a term that contains x. So here, this one, and this one are like terms. For the 70, we don't have any other separate separated numbers, so the 70 is the final answer also. So only we have negative 10x and negative 7x as like terms. We take it as integer numbers. It is negative 10. Imagine it negative 10. Imagine it this way: negative 10 minus 7. Negative 10 minus 7. As I told you, for subtraction of integers, the first number as it is, the minus sign becomes positive, and we change the sign of the second number. So it is negative 10 plus negative 7, which will be negative 17x. Yes, negative 10 plus negative 7 will be negative 17x, and the x to the power of 2 and the 70 will be written as they are. So the first part of the unit has finished. The second part is factorizing. Factorizing has many methods, like factorizing using the common factor, factorizing using the common bracket, factorizing using the grouping method, factorizing by the second degree equation, the difference between two square numbers, two perfect square numbers, and the sum or difference between two cube numbers. So all of these methods, you have to accompany them while you solving. Ax minus a y plus bx minus b y. So this is clear that it is factorizing using the grouping way, because here we have terms. We have four terms. And firstly, think of a, a, a common factor. Do we have a common factor in all the four terms? Like a is found in all the terms? No, A is only found here and here. The X is found here and here only. So that means we don't have any uh, variable or number that is common in all the equations. So this is the factorizing using the grouping way. Look at the steps. Step number one, look at the four terms carefully. If you find any two terms have a common between them, put brackets around them. Do this for the second pair of numbers. Look at the first two terms, ax minus ay. Do we have common between them? Yes, we have a. Here we have a. Here we have also a. So a as a common factor, that means we are going to take the first two terms as uh, common bracket. Here we put the brackets here this way: x minus ay plus bx minus by. After that, step number two, extract the common factor as what is done when factorizing by a common factor way. From this bracket and this bracket, extract the common factor. Here the common factor is a. Here the common factor is b. So by extracting the common factor from this bracket and the common factor from this bracket, it becomes this way: a outside the bracket, inside the bracket, x minus, when we take a from this, y. So it becomes a x minus y. From this one is b x minus y. After that, we extract the common bracket. We look at it. We find that x minus y and x minus y is a bracket is found in the two terms. Therefore, we are going to extract the common bracket, which is x minus y. Extract it out. Inside the bracket, what remains from from what remains from this is a. What remains from this is positive b. So we write it positive b. Factorize the following: 12x to the power of 2 minus 3. As I told you, the most important one is the common factor. Each question, think of the common factor. After you extract the common factor, then look at what type of factorizing should we use. Here we have, yes, common factor. Look at all terms and extract the common factor. Remember, firstly, look for the common factor as it may be the answer. Here, what is the common factor between this term and this term? If we take the 12, it is 3 times 4. The 12 is 3 times 4. Therefore, here we have 3 and here we have 3. We are going to extract it out. It becomes 4x to the power of 2 minus, when we extract 3 from 3, the answer is 1. Then, after that, the common factor sometimes is not the final answer, yet it is a step in solving as given here. So we look up for another method of factorizing. Here, 4x, the 4 is a square number, x is a square number, 1 is a square number. Therefore, it is the sign between them is minus. That means this is a difference between two square numbers. Difference between two square numbers, it has a rule which is plus y and x minus y. Within two brackets, x plus y and x minus y. So 2x minus 1 and 2x plus 1. Putting 3 outside the brackets. Now, the third one, x to the power of 2 plus 2x plus 1. So it is obvious that it is a second degree expression. We solve it in many steps. The first step, look at the sign of the absolute term. Firstly, we look at the sign of the first term. If it is positive, that means the two roots having the same signs. Why? Because the the absolute term is the multiplication of the two roots. The multiplication of the two roots, and we know that for from integers, the 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 two numbers, if the signs of them are same, so the answer will be by positive sign. Now, so the absolute term here by a positive sign, that means we put in our mind that the two terms or the two roots having same signs, but whether minus minus or plus plus, this is what we are going to know at the second step. That means the two roots having same sign and vice versa. And the bigger root will have the sign of the middle term. So as we said here, because the absolute term by a positive sign, therefore the two roots having the same signs. And then we look at the sign of the middle of the middle term. It is positive, therefore the two numbers by positive positive. We open two brackets, x x positive positive. Step number 2, in the case of similarity of signs, the middle term is the sum of two roots. Here, the signs of the brackets are similar to each other. Here positive, here positive. So that's the signs. So here this is the case of the similarity. The middle term is the sum of the two roots. And the absolute term is the multiplication of the two roots. When different, the multiplication of the two roots. Therefore, we think of two numbers. When we multiply them together, the answer is 1, and when we add them together, the answer is 2, which are 1 and 1. When we multiply 1 times 1 is 1, and when we add 1 plus 1 is equal to 2. Factorize the following: a times x minus y plus y minus x. Here, it is obvious that we are going to use uh, factorizing using the common bracket. But look at this one: x minus y and y minus x. X and minus y and y minus x, they have a relation between them which is x minus y is equal to negative y minus x. Therefore, we should modify this one to make it x minus y. To make y minus x minus y, we have to change the sign here. So now we have x minus y as a common factor or a common bracket. Here, when we don't have a number or common, we could take the common is 1, as in multiplication of 7 is 1 times 7. When we take the 7, the 1 remains as a placeholder. This means here, if we take x minus y as common bracket, what remains here is 1. So x minus y as common bracket. Here, inside the bracket, we have a minus 1 as placeholder. Then number 5, factorize the following. A to the power of 3 minus b to the power of 3. Directly, it is obvious that this is a cube number, this is the cube number, and this is a minus between them. So it has a rule says we take the third root for a to the power of 3, which is a, the third root for b to the power of 3, which is b. We take the sign, the similar sign here, the sign is minus. Therefore, we are going to write the sign here is minus. Then inside the bracket, we take the first to the power of 2. We change the sign. This is minus. Here we make it plus. We multiply the first by the second, a times b, ab, and then we take the second by plus to the power of 2. So this is a rule, directly we use it. Number 6, factorize the following. 2x to the power of 2 minus 18. As I told you, firstly, we are going to look for a common factor, which is the 2, because 18 here is 9 times 2. When we take 2 as common factor, what remains inside the bracket from this x to the power of 2 minus what remains from the 18, 9. Now, x to the power of 2 minus 9, it is difference between two squares, because x is to the power of 2 and 9 is 3 to the power of 2. So we can change it this way: 2 times x to the power of 2 minus 3 to the power of 2, and then we can say x minus 3 and x plus 3, and out the bracket we have the 2. Don't forget to write the 2. So this is the final answer. Moving to unit 8 questions. Solve the following equation: x to the power of 2 minus 5x plus 6 is equal to 0. Unit 8 speaks about the second degree equation, and when we want to solve the second degree equation, firstly, factorize it. As we uh, have known in the previous lesson, the lesson of unit 7 questions, we know how to factorize the second degree equation. Here, we have to factorize the second degree expression, and then we find the answer uh, the, by the following steps. Firstly, look at the sign of the absolute term. It is positive. So that means the two numbers having the same signs, either positive positive or negative negative. To know the type of the sign, we look at the sign of the middle term. The middle term is by negative sign, therefore the two brackets negative and negative. Then, as long as the signs are the same, negative and negative, therefore the middle term will be the sum of the two roots, and the absolute term is always the multiplication of the two roots. So two numbers, the multiplication of them is 6, and the addition of them is 5, 3 and 2. Therefore, this the second degree equation, we factorize it this way. This is the first step. The second step is to take the first bracket and we say is equal to 0. Either x minus 3 is equal to 0, therefore the value of x is what? Is 3. Therefore the value of x is 3. Or to take the second bracket and make it equal to 0, x minus 2 is equal to 0, therefore the value of x is 2. So the solution set is 3 and 2. Here, needless to write the brackets, the brackets, the paired brackets, because this is not simultaneous equation. Therefore, we just write the value of x, 3 and 2. Now, number two, if the two roots of x to the power of 2 plus bx plus c is equal to 0 are 2 and 7. These are the two roots. These are the solutions. So 2 and 7. These are the two roots. The question is find b. So there is a rule for b, which is the sum of the two roots by a negative sign, or we can say minus the sum of the two roots. Minus the sum of the two roots. So the sum of the two roots, 2 plus 7 is 9, and we put minus sign to it. So to find c, c is the multiplication of the two roots. 2 times 7 is equal to 14. So to find b, minus or negative the sum of the two roots. To find c is the multiplication of the two roots directly. Question number 3. Find the solution set of x to the power of 2 minus 3x is equal to 0. As I told you, we always factorize the left side here. X to the power of 2 minus 3x is equal to 0. And be careful that don't start solving unless the equation equal to 0. Unless the equation equal to 0, you cannot find the final answer. Here, x to the power of 2 minus 3x, there is no absolute term. That means c is 0. To find the answer here, we factorize this by any one of the methods of the factorization. Here, the suitable one is by taking the common factor. Here we have x, here we have x. So by extracting x as common factor, it becomes this way. X outside the bracket, inside the bracket, x minus 3 is equal to the 0. As we did above, here we say either x minus 3 and so on. Here we take x as an answer. We say either x equals 0 or x minus 3 is equal to 0. Therefore, x is equal to 3. That means the solution set is 0 and 3. So in all cases of second degree equation, we just factorize the left side. No matter the type of factorizing, here this is the second degree expression, and here the common factor. We find the answer. Finally, the exercise. Again, you can solve the exercise. Take a photo of it, then send it on WhatsApp or by email. This is the exercise in the second degree equation, the coefficient of x. We mean by the coefficient of x b. So, what is the rule of b? Here, the absolute term. Also, what is the rule of the absolute term? From the equation, x to the power of 2 minus 2x minus 15 is equal to 0. The sum of the two roots, as I told you, b here always is the negative of the sum. So when the question is finding the sum of the two roots, that means take b, change its sign. The multiplication of the two roots, we take the absolute term directly. Good. Question number 3. Form the equation that has 3, 7 as its roots. So we find b, we find c, and then we put them in one. Unit 10 is about the statistics. So statistics, uh, it contains two parts of questions. The first part when we have data, the second part when we have tables. So from the first question about data, from data to 7, 0, 7, 10, 7, 9, find the range. And we know that the range is the difference between the highest observation minus the lowest observation. So the highest one is 10 and the lowest one is 0, so it will be 10 minus 0, which is 10. The mode, the means the value that occurs the most. Here we find the 7 occurs 3 times and it is the highest rate. So the mode here is 7. The arithmetic mean, we find it by adding all the values together, dividing it by the number of the values. So the rule of the arithmetic mean is the sum of observations over the number of observations. So the sum of observations we will find it is 42, and they are 1, 2, 3, 4, 5, 6, 7. So 7 observations, it becomes 42 over 7, which is 6. So the arithmetic mean is 6. Now, question B, the table shows students' results. This is the table. This is the first column, which is the intervals. The second column, which is the frequencies. Here, the interval, we read it this way: 0 and less than 10. That means each value between the 0 and 9, we can consider it here. But the 10 itself from the second interval, not from the first interval. Now, the first question, how many students took the exam? So the frequencies represent the students. So if you want to find how many students took the exam, you have just to add the frequencies together. 13 plus 7 is 20, 28, and 31 students. The model interval. The model interval means the interval that is opposite to the highest frequency. We look at the frequencies. What is the highest frequency? Yes, it is 13. The highest frequency is 13. So we write the interval that opposite to it, which is 20 and less than 30. 20 and less than 30 is the model interval. Again, if you want to find the model interval, we look at the frequencies. The highest frequency we find is the opposite of the model interval. Number 3, if success is from 20, how many students succeeded? Now we look, as we said, here the 20 itself, not from the second one, but from the third one. The 20 from the third one. So how many students succeeded? That means the students got from 20 and less than 30 and from 30 and less than 40. All of them, they succeeded in this exam. So we just have to add the 13 and the 7 together. Not to write just 13, but to write 13 and 7 together, which is 20. So there are 20 students who took the exam and who succeeded on it. So the center of the last interval is 30 and less than 40. To find the center, we add the limits of the interval together and dividing it by 2. The upper limit is 40 and the lower limit is 30. So we say 30 plus 40 over 2. 30 plus 40 is 70 over 2, which is 35. Number 5, the length of the intervals. Here you have to choose any interval that you want to find the length of the interval. Any interval here you want to choose, you can choose it. For example, take the first one, 10 minus 0, which is 10. The length of the interval, like the mode, like the range. Here we also the question might come this way: the length of the interval or the range of the interval. Both of them mean the same thing. Like here we just subtract the upper limit minus the lower limit. Then B, the figure shows students' mark in an English exam. Its maximum score is 40. Study it and then answer. So now another way of representing data, like except the frequency table. Yeah, this table we call it the frequency table. This table we call it the frequency table. Then here we have this figure. These are the intervals. These are the frequencies. That means from 0 to 10, 5 students. From 10 to 20, 10 students. From 20 to 30, 20 students. From 30 to 40, 15 students. So here this figure we call it the histogram. Yes, this figure we call it histogram. How many students took the exam? As we said, how many students took the exam? We just have to add the frequencies together. Here the frequencies are 5 plus 10 is 15, 15 plus 15 is 30, 30 plus 20 is 50 students. How many succeeded? If success out of 20, as all as we said also, if the success from 20, therefore we take the frequencies above 20. We take frequencies from 20 and above. So we take two frequencies which are 20 and 15, which is 35 students. We take this one and this one because success from 20, this is 20 here, the 20 is here, then those students succeeded, those students failed. The model interval, we look at the highest frequency. The highest frequency is 20. So the interval that is uh, for the highest frequency is the model interval here. This is 0 to 10, 10 to 20, 20 to 30. So the model interval is 20 to 30. 20, sorry, 20 to 30. The center of the second interval, we look at the second interval, which is 10 to 20. To find the center of it, as we said, we add them together, 10 plus 20 over 2, which is equal 30 over 2, which is 15. So the center of the second interval is 15. Complete the frequency table, taking from up. Here, we have to complete the frequency table. From 0 to 10, how many? Yes, 5 students. From 10 to 20, 10 students. From 20 to 30, 20 students. From 30 to 40, 15 students. Now I think it is clear how to change from the histogram to frequency table and so on. Then number C, the figure shows the students' marks in a math exam, studied and then answer. So another figure is shown here. Also, these are the intervals and these are the frequencies, intervals and frequencies. But look, we here we plot from 0 to 5, we plot the center of it. We plot the center of it. So this one, we call it, the figure here, we call it the frequency polygon. If you remember in our first lesson, in true or false, the question is, incomplete, sorry, the question is, what is the connection between the centers and frequencies. So the connection between centers and frequencies is the frequency polygon itself. Find the model interval. Also, we look at the highest frequency. The highest frequency is 10. So the interval, which is 10 to 15. The answer is 10 to 15. Find the frequency of 20 to 25. This is 20 to 25. The frequency is 4. How many students succeeded? If success out of 20, also, as we said, this is 20. Those students succeeded. So here this is 4 and this is 3. 4 plus 3. Sorry, somehow mistake. How many succeeded? If success out of 20, this is 4 and this is 3. So is 7, not 32, sorry. How many students got less than 10 marks? So this is 10 less than 10. That means we take those frequencies, 5 and 2, which is 7. 5 and 2, which is 7. Question D. How many 8 values? How many? The number 8 values. The highest is 12. The lowest is 2. The arithmetic mean is 5. So this is the arithmetic mean, and this is the number. What uh, what is missed is yes, yes. This is the arithmetic mean, and this is the number of values. What is missed is the sum of the values. Find the range. The question of the range, as we said, the highest score minus the lowest score. The highest score is 12, the lowest score is 2. So 12 minus 2, which is 10. The sum of these values. Here we can use this triangle. This is the sum, this is the mean, this is the number of observations. To find the sum, we just have to point to the sum and then cover it by our finger. So the sum is equal to the mean times the number. So we multiply the arithmetic mean by the number of values. So the arithmetic mean is 5 and the values are 8. So we say 5 times 8, which is 40. If the arithmetic mean for 4, 1, 5, 7, x4 is 4. Find x. So here we have the number of values and we have the arithmetic mean. We can find what? We can find the sum. The sum of values is equal the number times the arithmetic mean, as we have known here in this example. Here how many values we have? 1, 2, 3, 4, 5, 6. We have 6 values and the arithmetic mean is 4, so the sum is equal to 24. And then we find the sum of the given values. 4 plus 1 plus 5 plus 7 plus 4 is equal to 21. Now the sum should be 24 and the sum of the given values is 21. That means the value of x is equal to 24 minus 21, which is 3. When we replace instead of x 3 and we make it, we will find the arithmetic mean is equal to 4. Uh, Moving on to the geometry questions. Firstly, starting by Unit 4 questions. Using the following figure, complete the proof of the theorem. In Unit 4, we have 4 theorems. Theorem number 1, as the plan of this year, is not included in the exam, but Theorem 2, Theorem 3, Theorem 4, each one you have to memorize and you have to understand the proof of the theorems. We choose today one of the proofs is the second proof, uh, the second theorem proof. Here we have the given the triangle ABC. In it we have AX is equal to XC. Here X is the point in the middle, because here it is clear that XC is equal to X because it is given here. And AA and AB is parallel to XY. This is AB parallel to XY. These are the given. What is required to prove that CY is equal to YB? Because of what? Because theorem 2 says the line joining, or the line is drawn from a midpoint of a triangle parallel to another side of it, is passing is bisecting the third side. Again, the line which is drawn from a midpoint of a side of a triangle parallel to another side Here, this is from a midpoint. Parallel to another side will bisect the third side. So we have to prove that the point y is the point of bisection. The point y is the midpoint of the side BC. This is what is required to prove. By is equal to cy. We want to prove that the sides here in red are equal. We have to have construction, which is draw KL is parallel to AB. We will draw a line here, name it KL, parallel to AB. By this way, LK or KL is parallel to AB. And from theorem 1, we said that if we have three parallel lines and we find that there is a transversal which intercepts congruent segments, and when we bring another transversal will intercept also congruent segments. So this is the idea. This is what we are going to prove, that these parallel lines which make congruent segments, if we bring another transversal will also make congruent segments. For the proof, KL is parallel to AB is parallel to XY. The three lines are uh, AB and XY are parallel because of they are given, and KL is parallel to them because this is construction. Construction, the thing that you made, but given the thing that you are given it. And AX is equal to XC, this is given. Therefore, KL, AB, XY intercepted congruent line segments on the transversal AC. AC here is a transversal, and BC is another transversal. Also will intercept congruent line segments. By this way, we can say BY is equal to CY, and this is what is required to prove. Again, we have here just two parallel lines. So by construction, we make a third parallel lines to them. Here we have three parallel lines intercepting by a transversal, intercepting congruent segment. So if we bring another transversal, also will intercept congruent line segments. By this idea, we say by is equal to cy, and this is what is required to prove. From unit 6, the inequality, sorry, triangle ABC. Here we have triangle ABC. AB, let it 5 centimeters. AC, let it 7 centimeters. Under the following questions, BC, it has to be greater than what? Yes, the third side. The third side is greater than. The third side is always greater than the difference. Yes, we look at the difference between the two sides. This side is 7, this side is 5. This side AC is 7, AB is 5. So the difference between them is 2. So the third side, it has to be greater than the difference. The difference is 2, so BC, it has to be greater than the difference. And BC is less than what? So the third side also is less than the sum of the two sides. The first side is 7, the second side is 5. When we add them together, the answer is 12. So BC, it has to be smaller or less than 12. If the question comes this way, greater than what and less than what, we say greater than the difference and less than the sum. But look at this question. If BC has an integer value like 3, 2, 1, and so on, the highest value for the side equals the highest value. We said that the highest value must be less than the sum. The sum between the 7 and 5 is 12. So the highest value must be what? 11. The highest value we can reach for BC is 11, and the lowest value also we subtract 7 minus 5 is 2. So the side it has to be greater than 2, which is 3. So the range for the possible, here we call it the possible answers or the possible values. The range of the possible values between 3 and 11. 3 because the difference between them is 2, so we start from 3, and the sum of them is 12, so we stop at 11. Moving on, unit 9, the circle. Find the values of x and y, the angles in the circle. Good. Here we have bunch of rules. We have to use all of them simultaneously to find the value of x and y. Here, this is a tangent. This is a tangent, and the value or the angle x is an angle that included between a tangent and a chord. There is a theorem says the angle which is included between a tangent and a chord equals the the circumferential angle which is made on that chord. So the angle that is made on the chord BE is 30. Look at the 30. 30, the angle 30 is made on this chord. Therefore, the value of x is 30. And then to find the value for y, look at dB. dB is passing through the center. Therefore, dB is what? dB is diameter. Therefore, the angle y should be 90 because any circumferential angle that is made on the diameter is equal to 90 degrees. Look at it. Okay, moving on to this shape. Look at the points A, B, D, C. The point A is at the circumference of the circle, also B, also D, also C. So all the vertices lie on the circumference of the circle. Therefore, the shape ABDC is a cyclic quadrilateral. And once we say that the shape is cyclic quadrilateral, that means we have uh, two important rules. The first one, the opposite angles are supplementary, as we mentioned before. And the second one is the exterior angle equals the interior angle, which is opposite to the adjacent to it. Here, the angle x, according to the cyclic quadrilateral, the angle x is exterior angle. This is the adjacent to it. This is the opposite to it. Therefore, the angle x is equal to y. Now we said that the angle x and angle y, both of them having the same value. Okay, we have to find either y or x. Look, this 40 is given, and 40 here is a central angle. Central angle on the arc CB. And look at the angle y is circumferential angle made on the arc CB also. And we have a rule says if we have a circumferential angle and a central angle made or based on the same arc, the central angle is the double of the circumferential angle. This is 40, so that means the y will be 20 and the x will be uh sorry, this is 80 here. It has to be 80. This is 80, therefore the y will be 40 and the x will be 40 also. And then look at this one, EA. The line EA here is what is a tangent. So we have to remember the rules of the tangents. This is what AB is, what AB is a chord. So the angle 40 here is an angle that included between a tangent and a chord. The angle included between a tangent and a chord equals the circumferential angle which is based or made on that chord, which is the angle y. Here the angle y, if you look at it, the angle y is based on AB. Therefore, angle y will be 40. Angle y will be 40. And for angle x, angle y will be 40. Not to remember it, not to forget it, sorry. Here, this is a tangent and this is a radius. The angle between the tangent and the radius is 90 degrees. We took 40 here, what remains is 50. What remains is 50. Good. So the shape A, B, C, D is cyclic because all the vertices lie on the circumference of the circle. Therefore, the 50 and the x are supplementary. The 50 and the x are supplementary. Therefore, x is equal to 130. X is equal to 130 and y is equal to 40. Look at it. Another question. Here, we don't have tangent and also we don't have cyclic quadrilateral. Look, the angle x is based on AB. Look at the ends of the angle x. This is on A, this is on B. Look at the angle 70 here is ended by A and B. The angle 70 is ended by A and B. Therefore, x and 70, both of them are circumferential angles based on the same arc. Therefore, x is equal to 70 also. And for y, it is the reflexive angle, not this angle. So the angle y is the reflexive angle here. If we make an angle here, it is central angle also on A, B. It will be central angle with the 70. Will be what? 140. Because the central angle, as we know, the central angle is the double of the circumferential angle that is made with it on the same arc. Therefore, in one point, around 1 point, the angle is 360. From the 360, we took 140. What remains is 220 because all this angle is 360. All the angle is 360. We took from it here 140. What remains is y, which is 220. Now look at the other question here. Also, we don't have tangent, we don't have cyclic quadrilateral, just angles. The angle 30 is made on the arc BC. The angle X is made on the arc BC, and both of them are circumferential angles. Therefore, X is equal to 30. And look at Y is central angle also made with them on the same arc. So the central angle made on the arc BC with uh, a circumferential angle will be the double of it. So the angle Y will be 60 degrees. And look at this question. Here, the points B, here this is B. The points A, B, C, E is what? A, B, C, E is a cyclic quadrilateral. Therefore, the opposite angles are supplementary. The angle 55 and the angle Y are supplementary. That means the sum of them is 180. So Y is equal to 180 minus 55, which is 125. And for X, Here, AD is a diameter, therefore the circumferential angle which is made on the diameter is equal to 90 degrees. We took from it 55, what remains is 35. So x is 35 plus the 55 is 90 because it is made on the diameter AD, and then y is equal to 125 because it is opposite to 55, and the shape ABCE is a cyclic quadrilateral. Now look at this one. Here we have tangent again. AC is a tangent. The the x, look, the x is all the angle till here, not till the end, and not till the first line, till the second line here. So it is uh, included between the tangent AC and the chord BD, between the tangent AC and the chord BD till here. So the angle included between a tangent and a chord equals the circumferential angle which is made on that chord. So the angle x is equal to what? Is equal to 50. The angle x is equal to 50 because it is the circumferential angle made on this chord BE. So it is equal to 50. And look, the angle 50 is made on the arc EB. The angle Y is made on the arc EB. And uh, the angle 50 is circumferential angle. The angle Y is central angle. Therefore, Y is double of 50, which is 100 degrees. Here, this shape is of a cyclic quadrilateral. This vertex, this vertex, this vertex, this vertex. So it is a cyclic quadrilateral. Therefore, the two opposite angles are supplementary. This is the first rule of the cyclic quadrilateral. And then this is the adjacent. This is the opposite angle. Therefore, the angle x is equal to 150 because the 115, sorry, because 115 is the exterior angle equals the interior angle, which is opposite to the adjacent of it. So the angle x is equal to 115, and the angle y is opposite to the 75, and both of them are supplementary. Therefore, y is equal to 105. Uh, Then again, look, AB is what? Diameter. AB is diameter. The angle x is an angle made on the diameter, so x is equal to 90. Look at the 35. Its ends are C and D. The angle 35, its ends are C and D. The angle Y, its ends are D and C also. Therefore, 35 and Y are two circumferential angles made on the same arc. Two circumferential angles made on the same arc are equal. Therefore, Y is equal to 35. This is the first part of Unit 9, which is finding the angles. The second part of Unit 9, which is the proof. The given here from this shape, DE is parallel to AC. From this shape, DE is parallel to AC. And what is required to prove here that angle BAC is equal to angle ACB. Those two angles, we have to prove that those two angles are equal. Angle BAC and angle ACB. To start the proof, look, DE is what? A tangent. DE is a tangent. BC is a chord. So as we mentioned previously, the angle that is included between a tangent and a chord equals the circumferential angle which is made on that chord. Therefore, angle EBC, this one, the angle between the tangent and the chord, this angle is equal to this angle. Look, angle EBC is equal to angle BAC. Angle EBC is equal to uh, BAC. Why? Because this is an angle that included between a tangent and a chord equals the circumferential angle which is made on that chord. That's why, because angle A here is drawn on the chord BC, so therefore we can say this is a theorem. Angle EBC is equal to angle BAC, and name this one and name this one. By the same way, we can say DE is what is parallel to AC. This is given. DE is parallel to AC. Therefore, we can say the angle C and this angle are equal because they are alternate angles. Angle C and this angle are equal because they are alternate angles. Here, the letter Z, this angle and this angle are equal because they are alternate angles. And then look at 1 and 2. EBC is equal to BAC. And then again, EBC is equal to BCA. That means BAC and BCA are equal. From 1 and 2, we get BAC and ACB are equal, and this is what is required to prove. Again, we have a tangent, the E, and a chord BC and another chord BA and another chord AC. So the angle between the tangent and the chord equals the circumferential angle which is made on that chord. So this angle is equal to this angle, and also this angle is equal to this angle because they are alternate, because DE is parallel to AC. Therefore, from 1 and 2, angle BCA and angle CAB are equal, and this is what is required to prove. Uh, the last proof here, the RT, we have this shape, the circle. O here is the center, AC is the tangent, AB is another tangent. Both tangents are drawn from one point A outside the circle. What is required to prove that the shape ABOC, the shape is cyclic quadrilateral. ABCO or ABOC is a cyclic quadrilateral. To start the proof, again, AB, we said AB is what? AB is a tangent. AB is a tangent. BO is a radius. Tangent and radius. We know that we have a theorem says that the angle included between the tangent and the radius is equal to 90. Therefore, angle ABO is equal to 90. This angle is equal to 90 degrees. Angle ABO is 90 degrees. Using the same way, AC is a tangent, CO is a radius. AC is the tangent, CO is the radius. Therefore, the angle ACO is equal to 90 degrees. And look at them by adding 1 and 2. ABO and ACO is equal to 180. ABO plus ACO is equal to 180. And they are opposite angles. Here, opposite angles, the sum of them is 180. We know that in any cyclic quadrilateral, the sum of the opposite angles are supplementary. Therefore, here we prove that the shape is cyclic quadrilateral because the angle B and angle C, when we add them together, the answer is 180, and this is what is required to prove ABCO is a cyclic quadrilateral. Because of the two opposite angles, their sum is 180. And this is the end of lesson 3 and the end of our series of revision.